All right, so I think this is recording. Let's take a look at these quadratic inequalities. If we look at number 11, um, let's write this in standard form. We've got 25x squared minus 40x plus 16 is strictly less than 0. Now, in my first step, I'm going to ignore this inequality and make it an equation, and I'm going to solve this equation. And a lot of times I will suggest that factoring is a faster technique than the quadratic equation. But here in this case, I don't know, because 25 times 16 is 400. And to think of two numbers that multiply together to give us 400, but add to give us negative 40, well, what about negative 20 times a negative 20? Yeah, that'll work. Okay. I stumbled upon it thinking about most of the time I'm not good enough at mental arithmetic. And sometimes when these numbers are large, I'll just use the quadratic formula because it might take me longer to come up with two numbers that multiply together to give me 400, but add together to give me negative 40x. And that's just my personal preference because I'm not really all that great at mental arithmetic. But I believe that negative 20x times negative 20x will do the trick. Negative times negative is positive. 20 times 20 is 400, and these add together to give me the negative 40x. So this I can see easily factors into a perfect square. Let's go ahead and do the x method, and let's go ahead and do a table. Some of you will see immediately how to factor this. But the table is a surefire way that will work every time. So if I write 25x squared and 16 along one diagonal, that's the first term and the last term. And these values that I found for my x, if I write them along the other diagonal, since this 16 is positive here, but this diagonal is negative, I need negative numbers out here. And a negative 4 times a negative 4 is positive 16. If I factor these, I see that this 5x divides both of those terms. 5x divides both of those terms. You can check that 5x times 5x is 25x squared, and you can check the rest of the entries in the table. So anyway, this factors to 5x minus 4 times 5x minus 4. And when you ever have a factor that's repeated in multiplication, you can write it using exponents. We can just write it as 5x minus 4 squared is equal to 0. So if we add 4 and divide by 5, we see that this is a solution, that this is a repeated solution. So this is kind of a rare situation in these quadratic inequalities. Let's shrink this up. So yes, with the quadratic equation, when the exponent is 2, we're expecting 2 solutions, but in this case, we only have 1 because it's a repeated solution. So if we go to our number line and put 4/5 in here as a critical point, I need to determine whether to shade or not to shade this number. So again, I look up the original inequality, and since it was strictly less than 0, then I leave this hollow. Well, now I have to think about this parabola. 25 is positive, so I know this parabola opens upward, and I know that it does come down, and it touches this x-axis at 4/5. That's the vertex. Now, I want numbers that are less than 0. Well, I can see that 4/5 will give me a number on the x-axis that will equal 0, Now remember, we don't want it in our solution set because it was a strict inequality. If I look to the left of 4/5 or to the right of 4/5, the parabola is above the x-axis. There's no value of x that I can plug in and do this arithmetic and get a negative number. So this quadratic inequality has no solution. I can't find any values of x that when you plug it in that satisfy this original inequality. All right, so let's take a look now at number 12. Let's distribute the 2 through here. 4x squared minus 6x is strictly greater than negative 9. Let's get this in a standard form. 4x squared minus 6x plus 9 is greater than 0. And I ignore the inequality and I make this an equation because I know the graph is a parabola, and by setting this equal to 0, I'm trying to find the x-intercepts of this parabola if you go to graph it. Let's use the x method to help us to factor this because the leading coefficient is not 1, and it's also not a prime number. But luckily, 4 doesn't have a lot of factors. The middle term here is negative 6x, and 4 times 9 is 36 x squared. So two numbers that when multiplied together give us 36, but when added give us a negative 6. Well, what do we have? We've got, well, let's think of factors of 36 that since this is we want both of them to be negative. Well, negative 1 and negative 36 definitely don't add up to negative 6. Negative 2 and negative 18 don't add up to that. Negative 3 and negative 12 don't add up to that. Negative 4 and negative 9 don't add up to that. Negative 6 and a negative 6 don't add up to that. So I don't see a way to factor this. So let's look at the discriminant. Let's go to the quadratic formula. Let's look at the discriminant. Let's identify A, B, and C. And the discriminant, part of the quadratic formula that's underneath the radical, is b squared minus 4ac. B squared, negative 6 squared is 36, minus 4 times a is 4, times c is 9. And what does that result in? Well, I need a calculator to figure that out. You might be able to do that in your head, but I cannot. I get negative 108. So not only can I not factor this, this equation doesn't have a solution. So let's come in and draw my number line, and I don't have any critical points on this x-axis. And since the parabola doesn't cross this x-axis, it's either the parabola has to either open downward or upward, but the vertex, it never touches this x-axis. Since 4 is positive, here I know that the parabola opens upward and it never touches the x-axis. So it wanted me to come up with values of x that when it does this arithmetic that it's positive. Well, positive values are above the x-axis. Hey, the solution set here is all real numbers. Any number that you want to pick. Doesn't matter how big, how small, whether it's a fraction, not a fraction. Plug it in and do this arithmetic, and I guarantee you it's going to be a positive number and not a negative number. So my solution set here is from negative infinity to positive infinity, because every number on this number line, when we go to graph this parabola, it's entirely above the x-axis. All of the y-coordinates are positive. So hey, I hope that helps, and I'll talk to you later.